Good afternoon, everyone. My name is Abhi. I'm going to be talking a little bit on the cloud-native stack which Oracle has and what our take is on the cloud-native side. So I just have a small deck, and then I'm going to delve into the demo real quick. So as everyone is aware, how the app dev environment has actually transitioned over a period of time. So people have moved over from monolith, and then we are moved more into the DevOps and microservices architectures, right? So we call the whole umbrella, also the industry calls the whole umbrella as cloud native. And particularly in this talk, I'm going to be focusing on mostly on the containers piece. So we got portfolio services both for DevOps and microservices and also for other cloud native stuff. But the majority of this talk is going to be mostly on the container side of things. So as part of our managed container offering, we actually chose Docker and Kubernetes as almost the obvious choices because of the industry adoption and also a significant amount of dev community around this. So our managed offering, which we call Oracle Container Engine for Kubernetes, is Docker-based and Kubernetes orchestration-based, fully open source. We're not going to fork any code. Everything is natively compatible with upstream Kubernetes. Now, the problem we're trying to solve here is basically Kubernetes has a bunch of challenges. If you want to deploy your Kubernetes cluster on your own tenancy, because Kubernetes has multiple moving parts, like you're managing the master, managing the API server, managing the etcd, so that can get really cumbersome as your cluster actually grows. And the other part is for containers to run on your virtual machines or bare metal, we got to have some kind of container networking provision, right? So we got to have native networking or probably do some overlay networking on top of a virtual cloud network which has to run. And then to add to the complexity, we got to add IAM policies, which team is going to manage which cluster, and DevOps integration, CI/CD pipelines, whole gamut of things. So how do we actually take care of this problem? Now, this is our service, Container Engine for Kubernetes. What we offer and how it's actually different from what other providers actually do is the master and the etcd parts and everything is going to be completely managed by us. And the master itself is fully available, fully highly available, as in it's actually spread across multiple availability domains, which means that it gives significant amount of HA. Not everyone actually does that. And then the other part is we also offer OCI registry, which is fully Docker version 2 compatible registry. For if you want to do your private Docker images, you can just put them on OCI registry, and then OKE can actually pull it out of the registry and then start consuming them. And the third, the most important one, is we can actually deploy bare metals into OKE cluster, right? I'm going to show a demo why that actually matters, why customers should actually care about it. But you can actually put virtual machines and bare metals into the same OKE cluster, OKE as in Oracle Cloud Kubernetes Engine. So that's the high-level picture of what OKE offering is. So price point of view, it's actually very catchy. So we don't actually charge for the master. You might scale up to 100 parts, 1,000 parts, millions of parts, which means that you have to scale your master as well. But we don't charge for the master. So we only charge for the underlying infrastructure, which is your networking and your storage or your compute. And OCE registry, you can dump in as many Docker images as you can. Doesn't matter. It's actually free of cost. We don't charge you for that. And so here, one thing I want to highlight is based on what we just talked about, we have native integration with our VCNs, as in you can actually select which subnets you can actually deploy your Kubernetes containers in, which nodes you want to select, and also which VCN you want to select. So full integration with networking, and also for load balancing, if you want to expose your service to outside world, it is fully compatible with our load balancer, public load balancer, right? And then it is developer friendly. I say that because we have native integration with CI/CD pipelines, and the most important of all is Jenkins, and also Jenkins X. Jenkins X got released in I think August this year, and no, actually May this year. And by August, we were able to support Jenkins X native integration into OKE. And why that matters? Only 2 providers actually do that, and we already have Jenkins X support for our cloud. Jenkins X is how Jenkins X is actually different from Jenkins is basically it's fully Kubernetes compatible CI/CD pipelining tool, and it's actually natively supported by us. And team-based access control, like I just said, we have IAM integration around Kubernetes, as in you can actually control policies, who can actually access the cluster, what level of access. You can get really granular there. So this is like the high-level picture of what OKE actually looks like. You have our CI/CD pipelines here, pushing code into OCI registry. OCI registry, OKE consumes the Docker images from OCI registry, deploys them into Nodepools. You can deploy Nodepools across 3 availability domains. The latency between availability domains is really low. And also you can deploy virtual machine Nodepools and bare metal Nodepools, and then expose them as a service to outside world using our OCI load balancer. At this point, let me just do a quick demo as why one should actually care about deploying containers on bare metal. Let's see. So this is a recorded demo. Okay, so the high-level architecture for this demo is basically we're going to create 2 Nodepools across 3 availability domains, one only for virtual machine 1.4 instances Nodepool, and the other for bare metal 2.52, which means 52 core bare metal instances across the second Nodepool, and everything is going to be in the same cluster. Having both VM and BM in the same cluster as 2 separate Nodepools, nobody does that. So, and we'll be deploying Apache Spark on this cluster, and we'll be running some big data jobs. And we'll be running Zeppelin to actually trigger these jobs, and we'll measure the performance across both the Nodepools. Any questions so far? All right, so the deployment steps at a very high level, this is what we're going to do. We're going to deploy the 3-node VM standard 1.4 shape, which has 4 cores, and then deploy Apache Spark and Zeppelin pods on this cluster. We're going to run the performance on these by running some Spark jobs. And then we're going to scale it out to multiple replicas. We're going to increase it to more pods, and then measure the performance. And then at that point, we're going to deploy VM standard 2.52 shape across the Nodepool, and then repeat the same steps, deploy Spark, and again measure the performance, and then we're going to compare the results and draw some inferences out of it. So how do you actually deploy instances into OKE? It's fairly simple. You just do a create cluster, deploy, and mention the name of the cluster. And let me pause here real quick. So you can actually select multiple versions of Kubernetes. So we offer the latest and the greatest 1.11 as well, and you can also roll back to 1.10 or 1.9. So we keep actually adding more and more latest images of Kubernetes. And as you upgrade, you can just upgrade it on the console, and we just do rolling upgrades, and you won't even lose any kind of a connectivity if you upgrade, right? So we just do native Kubernetes rolling upgrades, and that kind of, it's fairly seamless at the point. So that's we basically specify 2 subnets. These 2 subnets are for the load balancer if you want to expose it as a service. And then we add the Nodepool. Nodepool is basically where you actually add your nodes. And we are selecting Linux 7.5, Oracle Linux 7.5. And the compute shape itself is VM standard 1.4, right? And at this point, we're just going to add one node per subnet. You can add as many as you want. Just for this performance test, we're going to add 1 node per subnet and spread it across 3 availability domains. So this is what it looks like. And now we're going to go ahead and deploy Apache Spark. So we're going to start off with just deploying Apache Spark master and UI proxy pods. UI proxy is basically if you want to expose and view your Spark jobs running live, you can just deploy the UI proxy. That's not really a requirement. So once you deploy, right, let me pause real quick. So once you deploy onto OKE, what we do is you can actually export your kube config file onto your local machine and just keep running your kubectl as if you just run it on Minikube, right, on your local laptop. So it's really, you feel as if you're just working on your local PC. So here I'll be deploying a UI proxy. And as you see here, right, so you see external IP as pending. So once the load balancer actually comes up, you would actually see the public IP as well. So that's where you actually expose your public IP using the load balancer. So that's our native integration with the load balancer service which we have. So now we're going to run 3 replicas of Spark workers. And so this is just the Spark workers. And then we're going to deploy Zeppelin pod. Once that is done, we're going to move into the performance testing. So this is the CPU and the memory requirements or the allocations of this cluster. So at a high level, this is what is going to happen. Zeppelin is going to connect with the Kubernetes master, and master is going to connect to the worker node, which has the Spark master pod on it. And master pod is going to dedicate the console, one second, let me pause it. It's going a little fast. So the Spark master pod is going to give the control to the Kubernetes master, and the master actually deploys the worker pods. And that's when subsequently the master pod and the worker pods are going to communicate with one another. Here is the Spark computation we're going to run. Let me actually take it a little back. So the computation we're going to run is basically finding out how many prime numbers do we have in a data set from 100 million numbers, right? Natural numbers. So here, the cluster has 3 nodes, as we talked about, VM standard 1.4. So because it has 4 cores, but Kubernetes actually sees it as 8 vCPUs, right? So it doesn't see it as cores. That's why I mentioned it as vCPUs over there with 28 gig of memory. And per pod, per worker pod, what we're going to do is we're going to assign so that the worker pod itself can consume only 1 vCPU per pod and 1,000 megabytes of memory, right? And we're going to keep this very consistent across all the tests we're going to do. So just to make sure that we're not actually faking any of the results there. So connecting to Zeppelin, and then running our Spark job. So this computation takes about 387 seconds. Now we're going to scale the worker pods to 6 worker pods. Again, the same CPU allocation and same memory allocation. That's not going to change. Just more number of worker pods in the same Kubernetes node pool. So you see 6 worker pods there. We're going to expose the service again and connect. So this took about 354. So it's kind of down. The performance is good, but it's kind of logarithmic. It's not like it's exponential or anything. So now we're going to go ahead and deploy 2.52 core, really beefy bare metal instances to the same cluster, but in a different node pool. I'm going to just skip through this part because we already see how we deploy it.
So these are bare metal now that you're deploying?
That is correct. Yep.
Or it's a cross between 3 and 3. Okay.
That is right. Yep. So we're going to have both VMs and VMs now. But what we're going to do is we're going to use Kubernetes labels so that we have some kind of a node affinity. Now we're going to run the pods only on the bare metal and not on the VMs, right? Just for this testing purpose. But you can have both of them in the same cluster, and you can actually mix and match and play however you want. You can really run high performance computations on VMs and probably run your lower performance ones on VMs however you want it, right? That's the essence there. Now I'm going to deploy the same thing. Run the same perf test for 3 worker pods, like how we did on the VM 1.4 series node pool. This time, this time it's going to be 2.52 node pool. Start off with 3 worker pods. Let's see what the time it takes to complete. So that took 74 seconds. It's like blazing fast. Although you have the same worker pod, same vCPU, and same memory allocation, just that it is bare metal, you see the difference in performance. I'm going to explain real quick after we're done with the demo why we see a lot of difference there. Now we're going to scale it to 6 replicas. So last time for 6 replicas, we have seen about 350, I think. It took about 350 for the VM standard 1.4. Let's see how much it takes for the 2.52 this time. So basically, you're just parallelizing multiple Spark jobs across various worker pods. $39. To make it even better, we run it across 20 pods now, just really scale it out. You can actually scale, we didn't show this test over here, but we actually ran 20 pods across VM standard 1.4 as well. But when you scale it out really a lot on the VM series, the performance actually takes a hit, right? I'm going to explain why that takes a hit, but over here, when we scale it out to 20 pods, it actually performs even better. So it comes to close to about 30 seconds, right? Logarithmic again, but still very, very good performance there. So this is like pretty much the performance comparison, like containers on VM and containers on VM, okay? Let's get into the inferences after this.
You offer GPU-based bare metal?
We do GPU-based bare metal. Right now, it's not integrated into Kubernetes, but that's in the roadmap. That's going to be coming out pretty soon, actually. So if it's GPU, then it's going to be even faster, of course. Yeah. So this is basically highlighting that we can actually run virtual machines and bare metals in the same cluster. And over here, what this says is, with no hypervisor overhead, we get up to 30% performance benefit, right? Containers on bare metal perform 30% better. And that's really suitable for big data and HPC jobs, as we just saw right now. And the packing density of bare metal is significantly high when it comes to virtual machines. And why is that useful? That's because when you actually traverse across the network to actually communicate between the nodes, you actually get a lot of performance dip. So you get better utilization, resource utilization, when you actually pack it across bare metal instances, and then you don't have to really traverse across the network, right? So that, again, plays a significant role. And lastly, bare metals have 25 gig network bandwidth, but the VM standard or VM series standard ones actually have a kind of a bottleneck there. So we don't, we actually scale the bandwidth of the instances as the size of the instance actually grows. So the bare metals come with just, pure raw 25 gig bandwidth, and that's really useful for your big data applications.
And the cost differential, if we factor that into the performance differential?
Cost differential is basically you pay per core. It doesn't matter if it's virtual machine or bare metal, you just pay per the core.
So I imagine you must have an awful lot of customers that are opting for bare metal configurations.
Correct.
Okay.
Correct. Absolutely. So our commitment to open source is basically this. We are really actively committing to various open source projects very actively. We are one of the highest committers of Kubernetes if you look at the GitHub. We also have really cool side projects like Smith, Railcard, and CrashCard. Everything is actually available on Kubernetes. I'm sorry, on GitHub. So you can actually play with them. So Smith is actually fairly cool. It actually talks about something very novel, which is micro-containers, something which we actually are starting a rigorous movement on. So Smith is actually cool, so I would really strongly encourage you to check it out. And then we have containerized Oracle DB as well. If somebody is actually interested, you can actually run your Oracle containerized DB as well. We got MySQL operators for Kubernetes as well. So this is like the end vision. We want to envision our portfolio of PaaS or our container services should look like, wherein we have functions as a service, which just got launched, which is very similar, actually even better than Lambdas, because we actually run this natively on Kubernetes. And then we have a native CI/CD pipeline plugging into Kubernetes and then running whatever open source software you want to run on.